Hi guys, welcome back. In this video, we're going to learn that why the marginal cost curve cuts the average variable cost curve at its minimum at a lower level of output, while it cuts the average total cost curve at its minimum point at a slightly higher level of output. Now, while drawing these curves in the exam, you have to ensure that not only is the marginal cost curve intersecting the AVC and the ATC at its minimum, but it is intersecting the AVC at a lower level of output as compared to the ATC. And you can see that from the diagram that the quantity at which your marginal cost curve intersects the AVC is slightly less than the quantity it intersects the lowest point of your average total cost curve, right? Now there's a economic reason behind this. So let's say this is Q1 and this is Q2. Now if you notice that if I sort of extend this, so what you guys can see is that although the marginal cost curve intersects the average cost curve's minimum point at a quantity of Q1, right? But you can, and then after Q1, as you're increasing output, you can see the behavior of your average variable cost. Your average variable cost is actually turning, right? After this point, it sort of turns, right? It's increasing. But if you look at the behavior of the average total cost curve, if I extend a line all the way up till here, we can see that although after this point the average variable cost curve starts to go up, but the average total cost curve is still decreasing, is still going down, right? And it's still going down, and then the minimum point of the average total cost curve comes at a slightly higher level of output, and then it sort of takes a u-turn and starts to rotate. Sorry, it starts to then turn, right? It turns backs up again, and then it starts to increase. And the reason why this is happening is that you need to understand that basically you need to understand that the average variable cost excludes your fixed cost, right? It only reflects variable costs like labor or raw materials per unit, right? And the average total cost would include both your variable and fixed cost. So the average total cost would sort of be the sum of your average variable cost plus your average fixed cost. Now, since the thing is, if you look at the behavior of average fixed cost, it continuously falls. Although the rate at which it continuously declines goes down as you increase your output, the average fixed cost curves, although it is declining over a whole range of output, the rate at which it declines starts going down as you increase the output. That is why you see over a higher level of output, the sort of average fixed cost curve starts flattening out, representing that the rate, because obviously it can't just keep on declining even at a much higher and higher rates of output. So the rate at which AFC declines starts going down to a point that it sort of starts to flatten out, right? Now what you notice over here is that firstly the average total cost curve is above the average variable cost and it declines, but you see that the average total cost curve declines for a longer time before reaching its minimum point, while AVC reaches its minimum quite before, or slightly before, let's say. So AVC reaches its minimum earlier at a smaller output, while ATC reaches its minimum later at a larger output of Q2 as compared to Q1. And the simple reason is that marginal cost curve intersects AVC first and then ATC later, right? Because it takes more output for the sort of spreading of AFC to slow down and stop offsetting the rising AVC, right? What I mean to say over here is that, like I said, that at a larger scale of output, the AFC starts to sort of slow down, the decline in AFC starts to slow down, and to a point that it sort of initially what's happening was that you need to understand that at Q1, right, the average variable cost, then after Q1 average variable cost starts to go up. So after Q1 average variable cost starts to go up, but ATC is still going down, and the reason is that although AVC is going up, but AFC is going down still quite significantly, bringing your overall ATC down. But after a certain point, right, after Q2 when MC touches the average total cost minimum point, right, after Q2 when ATC reaches minimum, the effect of AFC declining sort of slows down, and it stops offsetting the rising AVC. Initially, it was offsetting the rising AVC. AVC was rising, but AFC was declining at a faster rate. It was offsetting it. But then after Q2, it would stop offsetting it, and hence you see that ATC also starts to go up, right? So the reason why this is happening is that simply because AFs, and the reason why, again, I'll repeat that the reason why, at Q1, although AVC has reached minimum but ATC is still declining, is because AFC is declining. You can see AFC declining, right? That is basically the reason, right? Because AFC is declining at a faster rate. That is why it offsets the fact that AFC is still declining after Q1, offsets the rise in AVC, hence it brings overall ATC down. But after Q2, the decline in AFC slows down to a point that it stops offsetting the rising AVC, and as a result, AFC might still be declining after Q2. We see that after Q2, AFC is still declining, but at a slower rate. And while the rate at which AFC is rising is quite high, and as a result, we see that after Q2, what's happening is that after Q2, what we notice is that after Q2, right, your AVC is, obviously AVC was increasing before Q2 as well. But after Q2, we notice that ATC starts to go up because AFC is no more offsetting the rising AVC, right? So we notice that both AVC and ATC starts going up. So this thing you need to make sure that, when you're drawing these curves in the exam, you're intersecting the marginal cost curve at the lowest point of the average cost curve at its minimum point and at the minimum point of the ATC curve, but it intersects the AVC curve at a slightly lower output than the ATC. Okay guys, thank you so much for watching. I'll see you all in the next video. Until then, take care.